Hello everyone, today in this video we'll be discussing the exam paper pattern of 18MATDIP31 and we have 5 modules here. The first module has 2 topics, complex trigonometry and vector algebra, and after that we have the module 2 and so on. So let's discuss each module one by one. In complex trigonometry, the two topics which you need to know are modulus and how to find the modulus and the amplitude. So what are the questions I'm going to solve in this question paper are means these topics are included. So all the type of questions are included in the previous year paper of JAN 2021. So we'll be discussing the topics which are there in the modules and then we'll be going on to the solutions. Okay, so the first topic is the modulus and amplitude. You need to know how to find out the modulus and amplitude of a given function, and second is the application of De Moivre's theorem. Moving on, we have vector algebra. We have 3 topics here: unit vector, triangles, sides, and perpendicular lines. Means 2 lines will be given, vectors will be given. We have to prove that it is perpendicular. Okay, and how to find out the unit vector, the formula of that, and the triangle sides will be given. We have to prove that the triangle is either right angle or it is isosceles. Okay, that's what about module 1. The module 2 is a pretty simple one because we have 4 topics here. The first one is the Maclaurin's series. We need to know the formula to derive the Maclaurin series. Just the question will be given and the formula is same for the Maclaurin series. So in that way we'll be doing the problems for Maclaurin series. And the second one is the Euler's theorem. Here also we have one formula. Then we have total derivatives. This is the partial derivative, this is the total derivative. Okay, and the Jacobins also have one formula. We'll be using that formula to find out the answer. So each of these question type is discussed in the question paper. That's about the module 2. And moving on, in the module 3 we have 2 topics, the formulas for gradient, divergence and color given. You just have to means know what type of formula to apply in which question. And another topic is the solenoidal and irrotational fields, and the questions are asked from these topics, and the reduction formula, so the proof and the problems. Okay, and the double and triple integrals. Then the last topic has last module has differential equation and a equation reducible to the exact form if it is not initially in the exact form. Then at last we have the Bernoulli's differential equation. Okay, so these are the topics from which the questions are asked. So each of these topics is important. So let's move on to the question paper. Before starting, if you like this video, hit the like button and don't forget to subscribe to my channel. And moving on to the solutions, the first question is prove that 1 plus cos theta plus I sin theta raised to m plus 1 plus cos theta minus I sin theta raised to n is equal to 2 power n plus 1 cos raised to n theta by 2 cos n theta by 2. Okay, so this question comes under the De Moivre's theorem. So the De Moivre's theorem formula is like you should have cos theta means 1 plus cos theta in that form. Okay, means you cannot have 1 here. It should be the form cos theta plus I sin theta. Since you have 1 here, the De Moivre's theorem cannot be applied directly to this formula. If you have a look, if you have once look at the main formula, you will just have the cos theta and sin theta terms. Okay, 1 should be removed from here. So what we'll be doing is we'll be considering 1 plus cos theta as r cos alpha. Okay, so that here it will be substituted as r cos alpha, and here it will be substituted as r sin alpha. R will be taken common, so you'll have cos alpha and sin alpha. That's the form in which the De Moivre's theorem's equation is. Okay, so we'll be substituting the these two things in the first part, and then we'll be finding out r square. R square is nothing but 1 plus cos theta square, and sin square here just squared and added these two terms. And then after we find out what is the answer here, and then we take the square root. Square root of this is nothing but 2 cos theta by 2. So we got the value of r here. Okay, then we have to find out the value of alpha. How we'll find out the value of alpha is we'll be using tan alpha is equal to means what is the y term divided by x term. Okay, so it will be sin theta by 1 plus cos theta, and applying the formulas, the sin theta formula and 1 plus cos theta formula, we'll get here tan theta by 2. Since tan alpha is equal to tan theta by 2, alpha will be equal to theta by 2. You have got the alpha value. Now we'll be substituting that in this equation. After we do that, this is the same equation which is given in the question, and after we take the common terms and simplify it, and after the substitution we'll be getting this form. And observe one thing carefully here. R power n is written here, right? R power n is nothing but what is the value of r we have got here, that will be substituting. Okay, means 2 cos theta by 2. In the place of r, substitute 2 cos theta by 2 and raised to n. At that time we will get these two terms, and this is from this term. Okay, means alpha is theta by 2 and n is here and it is cos term. So this is what we had to prove in the given question. Okay, just apply the formula and follow the steps, and the question under the De Moivre's theorem mostly come under this means of this type. Okay, Moving on, we have the second question, which is the equation is given to us. We have to express this in polar form and have to find out its modulus and amplitude. Three things are there. First, find out its polar form, find out its modulus, and then the amplitude. Okay, what is the polar form? Polar form is nothing but we have to have r cos theta and r sin theta. Okay, so this is the given equation here. So what is the r cos theta will be taking is x term. Okay, this is the x term, which is r cos theta, and y term is r sin theta. So here means a is nothing but 1, and here we have minus root 3, that is r cos theta and r sin theta. So r's value is 2 by this equation, x square plus y square's square root, so that we get as 2. So 2 cos theta is equal to 1, and 2 sin theta is equal to minus root 3. By that we can compare and find out what is the value of theta. After we have got the theta, we have found the amplitude, and modulus was nothing but the r value, and the polar form is at last you have to represent r cos theta plus I r sin theta. So just write r cos theta, and here write r sin theta. Okay. The next question is about the argument of this given term. So what is the argument is nothing but we have to express it in this form and find out the angle. Okay, angle of the given equation. That's nothing but the argument. Okay, so first write the equation which is given here, then normalize the denominator. If it is 1 minus root 3i, multiply with 1 plus root 3i. Okay, after the normalization of the denominator, you will get a term here which you need to simplify and separate the imaginary and the real part. Okay, if you separate that, you will get minus 8 by 4 here and 2 root 3 by 4 with I here. And after you have got this one, you have to find out the tan value. So what is tan? Tan is nothing but y by x. Okay, tan of y by x, if you take, you will get the value of angle. Okay, so tan inverse of y by x is the angle. So take tan inverse, and y's value is nothing but root 3 by 2 divided by minus 2. When you do that, tan inverse of this one is the angle. That's the argument of the given question. Okay, these questions are the first type, which is under the complex trigonometry. The second type of questions are under vector algebra, and the type of the questions which you can expect are three: the unit vector, and the triangle sides, and the perpendicular lines. So these three type of questions are given in the question paper. So let's discuss each one by one. This is for the unit vector. Okay, so see what is given to us: a and b. These are the two vectors given to us, and we have to find a unit vector perpendicular to the both sides a and b. When will how can we find out a vector which is perpendicular to both of these lines? Whenever perpendicular comes, keep in mind we have to find out the cross product. Okay, this is a, this is b, perpendicular to that is the cross product. Okay, how to find out the cross product is we have to write the a terms here and then the b terms here, which is these terms. Okay, these are the a terms 4, 3 and 1. Here we have 2, minus 1 and 2. This will be written here, and find out the determinant. After we find out the determinant, this is the thing which is perpendicular to the given two questions. Okay, given two vector equations. After we have found out that, to find out the unit vector, what you have to do is you have to find out this value and divide it by itself. Okay, what I mean is, how to find out the value of a vector is you will do square root of 7 square plus 6 square plus 10 square. That answer what you get, divide by each of these terms. Okay, that I forgot to do, but that's how you'll find out the unit vector. Okay, and moving on, we have the next question in which we have to show that the lines are orthogonal. Orthogonal means 90 degree. Okay, so two vectors are given, and we have to find out a plus b, then a minus b, and prove that it is orthogonal. So here I have written a plus b, adding the I, j and k terms and subtracting I, j and k terms here. After we have got these two things, to prove that it is orthogonal, we have to find out the dot product. In orthogonal, the dot product is 0. Okay, because a dot b is nothing but what is dot product? A dot b is equal to ab cos theta. So if the dot product is 0, what does theta means? Theta means it is 90, right? Cos 90 is 0, so it will become 0. So how to find out the dot product is that if you have to find out the dot product of these two vectors here, multiply these two terms and add with these two terms multiplication, add with these two terms multiplication. So when you do that and add, if you get a 0, the angle between these two lines is 90 degree. Okay, that was the first type of second type of question. The third type of question is the position vectors, and the triangle is given to us. We have to find out that it's isosceles triangle. Just use these points here to find write the equation here. After we have written the equation, the distances is calculated as this one. If the distance is to be calculated between a and b, subtract these both and square it. Subtract these both, write it and square it. Subtract these both, write it and square it, and take the square root of it. Okay, when you do that, you will get the distance of AB. Same thing do for BC and AC also. If you get two vertices as same means length, that means it's an isosceles triangle, because in isosceles triangle, two sides will be of same length. Okay, that's how you prove an isosceles triangle is isosceles. And that's what about that's all about the module 1. Moving on to the module 2, we have the first question: obtain the Maclaurin's expansion of log sec x up to the terms containing x power 8. Okay, in this question what you are supposed to do is first write the formula of Maclaurin's series expansion. Okay, so the formula is y of x is equal to y of 0 plus x by 1 factorial y1 of 0 and x square by 2 factorial y2 of 0 and so on. Okay, after I have written that, the first thing which you need to write is what is y of x. Y of x is given as log sec x. Okay, so y of x you will write log of sec x. Okay, and after that you have to put 0 in the place of x wherever you find in this equation, and after that what answer you get, that answer you store. Okay, and after that you do the same for y1 of x also. Find out the differentiation of this one. You will get y1 of x, which is 1 by sec x, then sec x differentiation is sec x tan x, you will get tan x there. Okay, like that. Put 0 in the place of x here, tan 0 is 0, then keep it as such and differentiate this again. Tan x differentiation is sec square x, so y2 of x is sec square of x, and keep on doing till you get the y power 8 terms. Okay, so y of 8 till you get, you have to do, and I have not done till there because it's understood that what is to be done, so you can carry on till the point which they have asked in the question, and after that write it in this form. Okay, means see the formula. You have in the formula you have got these things, right? The things of like y of 0, y1 of 0, y2 of 0, those things you have to substitute. Okay, this is y of 0, this is y1 of 0, this is y2 of 0 and so on. Okay, you have to just substitute that in the formula and write the answer. Okay, so that's a very important question. You need to know how to solve the Maclaurin series. And second type of question is this one. You have to do the partial differentiation. This for the Euler's theorem. So here the u's value is given as this one. What you have to prove is x into ux plus y into uy is equal to 2 sine 2u. So what is ux, what is uy? Ux means differentiate partially with respect to x, and uy means differentiate partially with respect to y. Okay, so how do you differentiate partially? That I have explained in the theory video, you can watch that. So here's the u term, and you will differentiate partially with respect to u first, and then partially differentiate with respect to y, and substitute those two terms here. Okay, x and y. But before that you need to check one thing. So you'll take this as f, and f is written as this one. Take x cube common from here, so you'll get y cube by x cube here, and take x common from here, you'll get x by 1 plus y by x. Okay, after you cancel this one, you'll get 2 here, right? So it is the homogeneous function of degree 2. You should get y by x here, and whatever answer you get here in the terms, that's the degree. Okay, after you get that, we need to get the answer as 2f. 2f means 2 tan inverse of u. Okay, so you'll just do that partial differentiation. What is the differentiation of tan u? It will be sec square u and dy by dx, del y by del x, and here also the same thing, but it's del u by del y. And how do you find del u by del x is what is the use value? Use value is this one, right? Partially differentiate with respect to x, and then partially differentiate with respect to y to find out del by del x and del by del y. After that, substitute those two things in the equation, and you'll get one answer which is sine 2u. Okay, that's what we have to find out in the question they're asked to prove. Okay, this was about the partial differentiation. The second one is the second type of question is the total differentiation. Here we have x, y and z, and here we have ux, uy and uz. Okay, so here it's dependent on u is dependent on x, y and z, and what answer we need to find is f. F is the function. Okay, so instead of x minus y, y minus z, z minus x, I'll take those three terms as p, q and r. So f is dependent on p, q and r. P, q and r is dependent on x, y and z. Okay, so it's a two type of function that is known as total differentiation. Okay, to find out to show that ux plus uy plus uz, first we need to find out what is ux, uy and uz, but directly we can't find. First we need to find del p by del x, del p by del y, del p by del z. Same thing goes for q and r as well. That's all what we have written here. Those things means partially differentiate with respect to x for each term p, q and r. Okay, so what answers you get, keep it as such, and observe here carefully what I have done. Okay, what we need, ux, uy, uz. These three terms, how we'll get? Ux is nothing but del u by del x is equal to del u by del p into del p by del x. So this will get cut, and we'll have del u by del x. Okay, like that we are doing. Okay, so here we will get del u by del p, keep it as such because that's not yet found, and del p by del x, this we can easily find. That's written up, right? So that's what we have to substitute here, and same thing goes for here and here as well. The left terms will be keeping as constant, and the right terms will be doing same for y and z as well. So what answers we get? Just add up the three terms. Here are the three terms which we need in the answer. del u by del x, del u by del y, and del u by del z. So add these three terms in the LHS part. In the RHS part, what you get? The answer is that. Okay. So in the answer you will get as 0 because the terms get cancelled. Okay. And here's another question about the Maclaurin series. I'll give a brief info what you need to do. This is log 1 plus x. We have to prove this one. Okay. So y of x is log 1 plus x. Right. First y of x as this one. Find out y of 0. Differentiate this and find out y1 of 0. Differentiate this and find y2 of 0 and so on. And keep on doing until like 2 or 3 or 4 terms you have to do. So after you have done that one, you will write it in this form. Okay. Means here what will substitute, what answers you got here. And this is the Euler's theorem. Here we have del u by del x plus minus y del u by del y 2u log u. Okay, so u is given as this one. So here the same thing you need to do, write u as such here and take log u because this we need to take in the denominators, means in the LHS part. So log u will be equal to this one, that is taken as f. Okay, now we need to prove it's homogeneous function. So take x cube common from this one and x common from this one. What answer we get here and what term we get here as 2. Okay, so it is of the degree 2. And applying Euler's theorem, we'll get this one. So we should get 2f because it's a degree 2. We should get in 2f form. Okay. So how we'll do that is, what is f? F is taken as this one, log u. So we'll just differentiate log u with respect to x, and here also log u with respect to y, and differentiating u log u will get 1 by u into del u by del x, and same thing goes for y as well, and it's equal to 2 log u. So rearranging it, we'll get this form. This is what we have to prove in the question given, right? So that's the final answer. Moving on to the last topic of module 2, which is Jacobians. You will be given with 3 equations, u, v and w, and what you have to do is you have to write ux, vx, wx, uy, vy and wy, uz, vz and wz. After you have written this one, just substitute the values. Okay, so what is ux? Partially differentiate with respect to x here, that you will be writing here, what answer you get. Then partially differentiate with respect to y for u, what answer you get, you will write here. Like that, keep on writing here and then find out the determinant. Okay, that's all what you have to do in the Jacobian. It's very easy one. Okay, so make yourself thorough with 3 things. First is the Maclaurin series, then is the partial and the total differentiation, and the last one is the Jacobians. Okay, moving on to module 3, we have the first topic, which is the speed and acceleration. Okay, so here the particle moves along the curve. The curve's equation is given here. You have to find out velocity and acceleration. See, if the point is given, how do we find the velocity? Differentiate this with respect to t, will get the velocity. Then differentiate velocity with respect to t, will get the acceleration. Then substitute t is equal to pi by 8. That's all what you have to do. Write the equation, differentiate, what answer you get. Substitute t is equal to pi by 8, one answer you will get. Same thing goes for acceleration also. In the acceleration also, you will do the same thing, and will differentiate what answer you got in v. The answer which I got in v is this one. So I'll differentiate this one with respect to t. So what answer I will get? I'll substitute the value of t as pi by 8, and one answer I'll get, that's the acceleration. Okay, so that's all what you have to find in this question about the acceleration and velocity. Moving on, we have the second question. Find out the unit vector normal to the surface. Surface equation is given. We have to find out a vector which is normal to the surface. Normal to the surface, if you have to find out the equation, we have to find out the gradient of it. Okay, so gradient I have explained in the theory video, you can watch that. This is the equation which is given to us. So what we'll do, we'll find out the gradient. Gradient means nothing but partially differentiate with respect to x, y and z for each for this same formula. When you differentiate that, you will get one answer. Substitute the value of 1 1 1 in the equation. So what answer you get? That's the vector, unit vector. Okay, so that's actually the vector. To find out unit vector, find out the value of it and divide each of these terms by these values. Okay, what the final value you get. So you'll get a unit vector here. Okay, the next question is to find out a constant a such that the vector f is equal to 2x x y square z square plus 2x square y z square plus ax square y square z. Okay, so this is the value of a which we need to find out. So if they have given this one, it is irrotational. Irrotational means curl of f will be 0. So curl of f, how you will find out? Write the ijk here, del x, del y and del z. Here you will write down terms associated with I, j and k in the given f. Okay, after that find the determinant value. You will get one answer here, that's equal to 0. So by that we can prove means find out the value of a, right? Because if in this equation it is equal to 0, what does that mean? If this is equal to 0, that means a should have some value which will be equal to this one, right? So 4 is equal to 2a, 2a is equal to 4, so a's value will be equal to 2, right? So that's how we'll find the value of a. Okay, next question is about the same thing here, just we have to find out f into f dot curl f is equal to 0. So this is the given equation, I, j and k terms. Write the same thing as we have done earlier also. I, j, k,
the del y, del x and del y and del z terms. This is the terms associated with I, j and k. After that, find out the determinant, one answer you will get here, and do the dot product with this answer, f into dot product of this. Okay, f means this is the given equation of f, do the dot product. Dot product means this one multiplied by the x term of that curl, and y term multiplied by this one, z term multiplied by this one. So here you will have the this one multiplied with this thing, this one multiplied with this thing, this one multiplied with this thing. These three things are nothing but the f values. F of means x value of f, and y value of f, and z value of f. When you do that and add up, you will get the terms cancelled, and the final answer is 0. Okay. The next question is the phi value is given, and we have to find out the gradient of phi and the value of it at 1 minus 2 and minus 1. So how do we find gradient? Partially differentiate with respect to x, y and z. So you'll get one answer here. Substitute the value of 1 minus 2 and minus 1, you'll get one answer here. That's the value of gradient. To find out the magnitude of it, just do the square root of 4 square plus 5 square plus 6 square. Okay. Then we have the vector field is solenoidal. Solenoidal means the divergence of f is equal to 0. How do we find divergence is partially differentiate with respect to x for this one, and partially differentiate with respect to y for this one. So if it's equal to 0 at that time, how can we prove? Just do the partial differentiation and add up, you will get that it's 0. So it proves that the vector field is solenoidal. So in module 3, you need to know the vector formulas and the divergence, curl and gradient formulas. Okay, most of the questions are asked from these topics. Okay, moving on to the next module, here we have two things, reduction formula, and another thing we will be discussing in the other question. So first thing, we need to know the reduction formulas proof. Okay, this same proof I have explained in the theory video, you can watch that. So I will just go through in a brief way here. So what is given is you obtain a reduction formula for this equation. Here what we have been given, sine power nx dx. Okay, so for that what you will do, sine power n minus 1 into sine x, n minus 1 and here 1, it will get cancelled and it will be n, right? The same thing here. So after that you will be writing the expansion of this formula, integration and multiplication expansion, you will get this one. So you will be writing the expansion formula here, and after that you will be taking the common terms. Here you have sine power nx, here also you have sine power nx. Take this in the LHS part and then take common. Okay, when you take common, you will get n minus 1 as separate here, that you take in denominator of this one. So you will get this answer here, that will be keeping as such. Now there is two possibilities, n will be either even or odd. Okay, if n is even, what we have to do? If n is odd, what we have to do? If n is even, you will get one answer here as in, if you take n minus 1 by n, n minus 2. If you take the n value as some even value, at that time the final answer is pi by 2, which is done here. For odd, you will get as 1. Okay, so that's all what you have to prove, and for pi by 2 the equation which you will get is this one at last. Okay, this whole term multiplied by pi by 2. Okay, next one is the application of the reduction formula. So here what you have to do, put x is equal to sin theta and differentiate, you will get dx is equal to cos theta d theta. Change the limits and then substitute the values here. So finally you will get here sin power and 9 means sin power 9 theta d theta. Okay, so what is sin power 9 theta d theta? This answer which we got here is n is equal to 9. So substitute the value of n as 9 here and find out the answers here. So what you will get is you will be starting from 7 8 here, 8 minus 2 6, minus 2 4, minus 2 2. Okay, divided by 9 into 7 into 5 into 5 into 1. Okay, since it is odd, we will be just multiplying 1 here. If it was even, like instead of 9 it was 10, you have multiplied pi by 2 also. Okay, so what answer you get after multiplication, that's your final answer. Moving on, we have the double and triple integrals. The way, if you need to know, if you get to know how to find out the double and triple integrals, you can solve any question. Okay, so what you need to basically do is here, see two terms are there, x and y terms. Okay, if you are differentiating something with respect to x here, make sure that the limits are in y. Okay, it's like that. Okay, if you are differentiating with respect to x first, the limit should be in y, and if it is y first, the limit should be x. Okay, that's all what you need to keep in mind, and observe very carefully what we have been asked. Okay, evaluate the given integral where r is the first quadrant of the circle. The equation is given, so this is the first quadrant of the circle. Okay, and what I told you, if you are differentiating with y first, at that time the limit should be of x. So here I am differentiating with respect to y first, dy, so the limit should be in x. Where is y going from and till where? See, y is this value, right? This value is going from here till here. Okay, so what is the value at this point of y is nothing but you will keep y as such here, and it will be a square minus x square, then y will be equal to root of a square minus x square. That is what you are substituting here, the limits, and then find out the differentiation. After you get the differentiation value, you will just substitute the limits here. After that, do the same thing for x as well. So, you will get an answer here, and find out the integral separately and substitute the limits. You will get an answer here. That is your final answer. That is how you carry out the double as well as triple integration. Okay. The next question, the same thing as we have done for the previous question. Here it is cos power nx. You can go through it. This also I have explained in the theory video. So, if you have any doubt, you can watch that. And here it is the next question, x square 2ax and minus x square. The only thing which you need to know is practice. Okay, means more practice you do, you will get more type of idea of what type of question how to solve. Okay, so here what you will do, x you will substitute as this one, 2a cos square theta, and when you substitute that one, and just simplification purpose, nothing special in this one. So, you will just simplify these things, and finally you will get the equation in this form. Here if you get in this form, this is the reduction formula, right? Sin power m and cos power n. So, note down the m and n values and then expand it. So, here m is equal to 2 and n is equal to 6. So, we will write this equation, substitute the values of m and n to get the final answer. Okay, here it is 5a square pi by 8. Next question also same, you have just use the triple integral formula. So, here I will be explaining what is happening here. First, differentiating with respect to y. So, if you are differentiating with respect to y, the x and z term should be there. Okay, then differentiate each of these terms and substitute the limits, you will get one answer here. After that, if you are differentiating with respect to x, at that time the limit should be of z, because dz is remaining. So, do the same thing here, simplify and keep on doing until you get the final answer. Okay, there is nothing special, you can easily do it. So, here you need to know the reduction formula and double and triple integrals. That is a very important type of questions from this module. Okay. Moving on, we have the next module, which is module 5. Here we have the differentiation, means differential equation, as well as the Bernoulli's theorem. Okay. So, here is the Bernoulli's equation. It is of this form, dy by dx plus py plus is equal to qy. Okay. Sorry, qx. Okay. That is of this form. So, you get the value of p and q as cot x and sin x, then this is the formula which you have to apply, e power integral p dx. When you apply that answer, means you when you apply this formula, you will get the answer as sin x, and you just have to apply that same thing in this equation. Okay, do that and find out the integral, you will get the answer here. Okay, just you need to identify what is the type of question, then applying the formula and simplifying is very easy. Okay. And the next type of question is this one. Here we have the partial differentiation. Separate these two terms as dx and dy separately and then integrate. Okay, that is all. Dx one side and dy one side, and then integrate to get the final answer. Okay. Next one is this one. Here it is not of the form of linear Bernoulli's equation. So, here it is y square. We have to divide by y square to get in the linear form. So, when you divide by y square, you will get this form. Take 1 by y as t. At that time differentiate, you will get 1 by y square dy by dx as dt by dx, which is written here, and you will be using that one in this equation. Okay. And 1 by y you will take as t, and t will be written here, and same thing you have to do for the whole equation, and you will get the linear equation form, because since you have divided by y square, here it is of the linear form. Okay, y square has gone now. So, you will get x here, and that is q is x, and p is 1 minus 1 by x. So, we will just use this same formula which I have used earlier. The only difference in this question is that convert the quadratic into linear. Okay, then apply the same formula to get the final answer. Okay. Moving on, we have the this is also the type of question which can be asked in exam. Here you have to do the partial differentiation of m and n. Okay, del m by del, I guess it is y or x, I am not sure, but this is the thing. What you have to do is, first you have to check if it is the exact equation or not. So, here what you will be doing is, first take this term here and then cross multiply, you will get these two terms in the with dx and dy. After you have got that, what you have to do is m is equal to this one, m is this one, this is m. Okay, the left part is m and right part is n. Left part is m and right part is n. Okay. So, you will be doing del m by del y and del n by del x, and what answer you get here. If it is the same, it is exact. If it is not same, one other step you have to do, that I will be explaining in the other question. Okay. So, once you have got it exact, the answer is simple. You have to use the official formula, which is, not sure about the official formula, but I have explained in the theory video, you can watch that. and applying that formula you will get the answer here. Okay, after integration, I guess it is m dx plus n of y dy. So I explained in detail, you can watch that, and just applying that formula you get the final answer here. Okay. Next question is the quadratic Bernoulli equation. So here we will be dividing by y square, the same question. Okay, this is the same question which I have discussed in this video only, in the previous OR question. So that's the same thing. It has been asked in 2 times in OR. So here is the differential equation. This is a type of the question which is a bit harder. So if this type of question comes, first you have to convert dx by dy and write it separately. Okay. After that, dx by dy plus, you have to take this in the other side and just keep y terms here. Okay, here you will have x and x with that here. So this is of the form dy by dx by dy and p x and q y. Okay, this of this form. This is also in the same form as of the Bernoulli's equation. So here what we will be doing, we will be taking the p and q values as same and applying the same formula. E is to integral p dy instead of p dx, because it's the reverse Bernoulli's equation. So you will get the same thing what you have done earlier, just instead of x it is y and instead of y it is x. Okay, just apply the same formula and write down the simplify the equation to get the final answer. Okay, and remember one thing, if you have to simplify, since it's of the term, like in denominator it is the root thing, so you will take the whole term as t, means sin inverse of y as t, differentiate this, you will get 1 by root of 1 minus y square as dy as dt. So substitute these two things in the equation, you get the equation in the form of t, so it will be easier to simplify. So keep this in mind. Okay, after you have simplified, you have to re-put the value of t which you have taken, and you have to put x and y as 0 as given in the question, so you will get the final answer. Okay. So in this paper, almost all the type of questions which can be asked in exam are covered. So make sure you have solved more of these type of questions, and thank you for watching. I'll see you in the next one.